Hi, welcome to Learning Monkey. I am Raghu here. In this class, we'll discuss about how to find the Euler's pi function value. That is what we are going to understand in this class. In our previous classes, we clearly discussed about what is meant by Euler's pi function and what's that value means. Please watch those classes and come back here. The link for the playlist is provided in the description below. See, they have provided 4 formulas in order to identify the Euler's pi function value, but identifying the value is not important in our subject. But whether can we write in cryptography, it is important. Can we write an algorithm to find this Euler pi function value in polynomial time? Because in our last classes, we clearly discussed that algorithms that execute in polynomial time, they can be accessed, they can be executed in limited time, means 1 minute, 2 minutes, like that. If it is going to exponential, we cannot execute those algorithms. These basic concepts we discuss in our design and analysis of algorithms playlist. If you have any questions regarding that, please watch that playlist and come back here. Now coming to, let's understand. Let's understand this, how to find that. With example, you are going to get good clarity about how to find the Euler's pi function value. The first one is phi of 1 equal to 0. What is phi of 1 means? What is Euler's pi function value? The numbers that are less than 1 and they are relatively prime to 1. Those numbers we have to consider. Less than 1, there are no numbers. So that's why how many numbers are there? 0 numbers are there. So that's why phi of 1 is equal to 0. Similarly, phi of p, if p is a prime number, then what is the Euler's pi function value? P minus 1. Yes, prime number, the numbers less than p, any number that is relatively prime to p, because p is a prime number. Let's take example, phi of 5 is equal to 4. That is equal to 1, 2, 3, 4, 1. GCD of 5, 1 is 1. GCD of 5, 2 is 1. GCD of 5, 3 is 1. GCD of 5, 4 is 1. Because 5 is a prime number. That's why phi of 5 is equal to 4. Phi of p is equal to p minus 1. Coming to the next one, phi of m multiplied by n. This can be written as phi of m multiplied by phi of n. When m and n are relatively prime numbers, then only we can apply this formula. Similarly, the next one is phi of p power e is given as p power e minus p power e minus 1. If p is a prime number and e is some constant, integer constant, you take any integer constant. With examples, you are going to get clarity about this. So we can use this, any of these 4 formulas in order to identify the phi of n value. Let's take an example, phi of 10. If you want to identify the phi of 10 value, 10 can be written as 5 multiplied by 2. 5 and 2 both are relatively prime numbers. So this can be applied as phi of 5 multiplied by phi of 2. We are going to use the third formula. And phi of 5 means 5 is a prime number. We are going to use the second formula. 5 means 4 values. Phi of 2 means 1 value. 4 multiplied by 1, which is 4. Phi of 10 is given as 4. Yes, 1, 3, 7, 9. These are the numbers which are relatively prime to 10. So the next one is phi of 49. 49 can be written as 7 multiplied by 7. Relatively prime numbers. So phi of 7 multiplied by phi of 7. So 6 multiplied by 6. Phi of 7 is a prime number. So 6. Phi of 7 is 6. 6 multiplied by 6, which is 36 values are there that are less than 49 and relatively prime to 49. Similarly, phi of 240. 240 can be written as 2 power 4 multiplied by 3 power 1 multiplied by 5 power 1. 2 power 4 means this can be written as p power e. 2 power 4 minus, we are going to use the fourth formula. P power e means 2 power 4 minus 2 power cube, e minus 1. Similarly, this can be written as 3 power 1 minus 3 power 0. This can be written as 5 power 1 minus 5 power 0. When you multiply all this, you are going to get 64. So phi of 240 is 64. Like this, using these four formulas, we are able to identify the phi of Euler's phi function value. But the thing is, we are not going to use this. Whether can we write a polynomial time algorithm for finding the Euler's phi function value? No, we cannot write. Why we cannot write? Because see, you take any number, that number can be written in the form of factors of prime numbers. These basics we discussed in our previous class, and we clearly discussed with mathematical proofs in discrete mathematics playlist. So you can write any number in the form of factors of prime numbers. So in order to identify the Euler's phi function value, we have to write the number in the form of prime numbers. But in our last classes, we clearly discussed that identifying a prime number for a large number is an exponential time algorithm. Here and in our last class, we clearly discussed identifying the factors for a given number is also an exponential time algorithm. So it is not possible to write an algorithm that can execute in a polynomial time for finding the Euler's phi function value. This point you need to understand. This point we are going to use in cryptography in our coming classes. So identifying the Euler's phi function is not possible for large numbers. Large numbers means in our cryptography we are having 1024 bits. That's the large number. That's the size of numbers we are going to consider in our next classes. Hope you understand this class. If you have any questions regarding the concept, please post your questions in the comment section below. Thanks for watching. If you haven't subscribed to our channel, please subscribe to our channel and press bell icon for the latest updates. Thank you.